Hello, everyone. Welcome to a new episode of the Good Faith Idea Exchange.
The Carrington event is not something we know a spectacular amount about because it's going to happen back in 1859. And so our resources to understand things like solar activity were limited. What astronomers could do at the time was look at things like sunspots, how many there were, their motion, things like this, to try and make some understandings of what's going on. But they could also, from time to time, see large events like coronal mass ejections, where these are very large, very violent outbursts from sun that take what you always have, which is what we would call the solar wind, which is charged particles leaving the solar atmosphere at relatively high velocities, and those are dangerous on their own, generally speaking. But fortunately, Earth has a lot of defenses against this. Primarily, its magnetic field and your atmosphere. Still, some stuff gets through. But when you're looking at something like a solar flare or a CME, you're now dialing that up to a more significant amount of energy being expelled from sun at any given moment. Take this as, your wind on an everyday basis doesn't really phase you that much, but on a hurricane, you might want to watch out. And that's not a bad way of putting things. But yeah, we could have at any given moment a large scale outburst from sun that happens to go in Earth's direction. And that's what happened back in 1859. There was a large solar outburst, and it happened to be directly in the path of where Earth was at the time. And so the sunlit side of Earth got walloped pretty hard by a massive onslaught of charged particles that were going to interact with Earth in a significant way. Because what's going to happen at that point in time is, for one, how most people are going to know something's going on. There will be significant auroral discharge at significantly lower latitudes than normal from time to time. If there is a significant solar event, or no, I don't want to say significant, a reasonably significant solar event, you could see auroral activity down in Rhode Island and southern New England, for example. That's not unheard of and not something that would worry me on a day-to-day basis. It's a nice thing. But when you start seeing it down in kind of the southern United States and the southern latitudes, that's significant. And the reason why is because Earth's magnetic field, your primary line of defense, is strongest at the equator-ish, and weakest at, again, kind of your semi-polar regions. And so New England, being in kind of the middling latitudes, is in the middling defensive line. But these charged particles are going to come in, and they're going to interact with what limited human technology they had at the time in a very particular way. Put simply, we're going to induce a lot of current in a lot of things. Now, fortunately, in 1859, there were not a lot of things that human beings used that carried a current in it. Light bulb wasn't really in use yet of any meaningful way. Electrical grids weren't in use in any meaningful way. So that wasn't a mega problem. But there were telegraph lines, and telegraph lines work by carrying a current through them. And so a massive amount of current was sent through telegraph lines, shocking a lot of people, melting lines, causing limited fires here and there. It's something that's important to say that it's not going to do anything directly to people. Laughable.
Right, right. Now, Professor, I know you just said, back in 1859, it was, simple stuff like telegraph wires that were taken out. But what would happen if an event of the same magnitude were to hit us today?
So we'd have to start thinking our way through it. So basically, what you have to say is that one side of the planet is technologically dead, and the other side is okay for now. It's not quite that simple, but the sun side, whatever side of Earth was daytime, is with the side that got hit. You're facing sun. That's why it's daylight. And if it's nighttime, then your side is theoretically more or less okay. So when I say all your technology is dead, we tend to forget things like our cars have computer chips in them. We are a bit more aware of that now, kind of post-COVID with the chip shortage these days. But yeah, most cars will not start. If you have a classic car, you're probably in decent shape depending on the situation and the severity of the event. But almost no one's vehicle is going to start. I hope you've got a bike, although it really won't help you long term.
Right.
If you were hooked up to technology to keep you alive, you were on the initial death count. Anyone who is, medically kept alive, we have to have you hooked up to a machines, people on dialysis, anything like this. Remember, your generators aren't running. It's not like we have backup power. The Jennies are dead too. So there is literally no power. So anyone who requires power to be literally kept alive is going to die in whatever amount of time they require to die off of that power. All the airplanes in the sky will drop out of the sky. Certainly some very talented pilots will probably be able to glide to a landing depending on where they are. Again, the very sensitive avionics. Most airplanes these days are fly-by-wire, which means if I take out all of your electrical systems, the rudders aren't connected to pedals, basically. So it would be bad. I know it spills out from there. The long story short is billions. Well, I guess you could get really lucky and have basically the Pacific get mostly hit. You have like California and Japan and the east coast of China, I suppose. I need to really map it out. I mean, that's your real best case scenario, is that like Hawaii dead center, because that's just where the lowest density of humans is.
Right.
And otherwise, again, if you have like kind of Africa, Europe, Asia facing, that's a mega blow. You have 3 billion people living in Southeast Asia. So we might want to kind of move it over so America takes a bit more of the brunt. Maybe we push it over to the Rockies to try and minimize the effect. But if you like North and South America, again, could easily be in the line of fire. That's another several billion. The deaths would be huge. It's mostly because of starvation, disease, deprivation. We've seen this kind of a taste of this, and we may have discussed this in class, depending on what it was. It's funny for me. I've spoken about these things for years, and then COVID hit, and I kind of got to look at my class that semester and go, "Told you." As people started making a run for toilet paper and for food, and I sold more livestock and produce during the spring of 2020 than I ever have at any point in my life. Suddenly, everyone was very interested in where their food came from because they realized it doesn't magically show up. And we are very, very dependent on these services. But also don't forget that all of the satellites in space that were on the side that could be seen, they're gone. They are completely gone. If the International Space Station got walloped by that, we have just said goodbye to a few astronauts. Could they make it home? Oh God, that would get ugly. Maybe. But it's these kinds of things where you kind of have to look for some of the edge cases. It just gets ugly. There's not a lot we could do. Unfortunately, humanity has put itself into a position over the last 12,000 years of building civilization to build this inverted pyramid where it's easier and easier and easier as time goes on to knock you down. The quick example I might have given you in class is that we have artwork on cave walls, we have writing on cave walls, we have carving in stone from literally thousands, tens of thousands of years ago. In one moment with a Carrington level event, I can take your entire life, just you as a person, and your massive digital footprint, and it's gone. Like it never existed. All that stuff that we've built up, all of these photos and videos and then recordings and anything, are all of our digital art and all these other things. These are very important things. It's not to say that like physical art is more meaningful or something like that. But again, think even as I'm trying to let my brain go places, your dollar bill will be fine, but your cryptocurrency could be gone. Depending on how distributed the network is. It's stuff like this, where suddenly if you literally go from a physical currency to an entire digital currency, again, now you've got a completely different event. Now you've got no money after that happens. And, looking to the future, I wouldn't be entirely surprised to see everyone eventually going to some kind of a digital currency. It seems to be the trajectory of things. And as we continue to do that, it just becomes easier and easier to just knock humanity over. That's what I mean by the idea of an inverted pyramid. The bigger it gets, the easier it's going to be to just knock the whole thing over. And there's not a lot we can do about it in that sense. The best thing you can do, if you want to know the right answer, is you need a Mars colony. A lunar colony would not really help you because if it hits Earth, it's probably going to hit Moon. The only upshot on Moon might be that an early lunar colony, you see, without Moon has no magnetic field, no atmosphere, kind of a duh, at least in the second one. It has no protection from solar wind and solar events. And so when we have sent human beings, the handful of them, 18 dudes off the top of my head, who have gone out and been exposed to those winds, we have a good understanding of the amount of radiation they're intaking. And again, as we may have discussed in class, radiation A is a word we should probably define in a minute in a better sense, but B is not instant death, and it depends on a lot of different things. Humans take a lot of radiation every day, a lot of different varieties. So on Moon, though, if we're going to spend a long time there, so again, our Apollo astronauts, they're the ones who've done this. They spend a very limited window of time out there, and we give them a good checkup when they come back. If you're going to be on Moon for a prolonged period of time, we have to shield you. We're not just going to let you take it. So they're going to be underground. And if we put all of our technology underground as well, that might be enough to give a reasonable amount of protection. But really what you want is a Mars colony, because it would be just be a really bad day. If Earth and Mars happen to be lined up both in the line of fire from sun, because that just wouldn't happen almost ever.